Hi guys, welcome to this, my video on divisibility and prime factorisation. My name is Darren, Maths Guru. Really good to see you. Hopefully you are well. We're going to get into this in a moment. What am I going to look at? Factor trees, prime factorisation, highest common factor, lowest common multiple, and some divisibility facts. Yes or no? Look, if you're watching this on YouTube, can you do me a favour and subscribe and like the video? Greatly appreciated. YouTube now apparently works on likes. And so my videos get about 3 likes each. If you can do that for me, greatly appreciated. Now, what on earth is divisibility and prime factorisation? There are times where we need to know how to find the lowest common multiple and highest common factor of a couple of numbers or even a set of numbers, and the way to be able to do that is a really funky way. All right, so first thing I'm going to do is show you how to split up a number into the product of its primes. Okay, you're going to say what? So product of primes. How do we do that? I'm going to start with a really simple number first. I'm going to say, well, okay, let's start with the number 24. Why am I going to start with that? Why not? Now, we know what our prime numbers are. Hopefully, prime numbers are numbers that are divisible by 1 in itself. That's certainly one rule, but people get very confused then with the number 1. So what they say is they have to have only 2 factors. I like that, only 2 factors, which are generally going to be 1 and itself, yes, which is why the number 1 now can be excluded. Right, remember number 2 is the only even prime number, okay, because it has 1 and itself. Right, so how do we do this? Well, what I tend to do now is I look at the number and I go, right, I'm going to split it up into 2 numbers that are multiplied by side. I'm going to split it up into 2 numbers that multiply to give me the number above. So I could come up with all sorts of things like 3 and 8 and whatever else, but I don't. If this number here is even, I'm pretty good at dividing by 2. So what I'm going to do now is divide that by 2, which means I have 12 here. So think about what I'm trying to say now. We have 2 times 12 is 24. Now, whenever I hit a prime number, or whenever there's a prime number on one of those branches, I tend to put a circle around it, and then I'm stopping. Right, so now, what have we got? 12. Can I split 12 up? Well, yes, it's an even number, so that's 2 times 6. Any of those prime? Yep. So I'm going to put a circle around the 2. What about 6? Yep, I can split up into 2 and 3. And as both of those are prime numbers, and don't worry about the colours, I'm just doing this for, well, actually, the PDFs for you to download, right? So what happens is if you're on mathsguru.com, you can fly over there and download exactly this document that I'm working on now in all the colours so that you can add more notes to it if you want. Now, because I've got nowhere else to go, I'm done. And what this means is I can now write 24 as 2 times 2 times 2 times 3. Where did I get those numbers from? 2 times 2 times 2 times 3. Now, some of you are going to go, no, it doesn't make 12. Yes, it does. Let's just check. Well, 2 times 2 is 4. 3 times 2 is 6. And 4 times 6 is, in fact, 24. And I think I just said 12. Anyway, 24. So that actually does work. Why is this important to me? Well, actually, this process helps us then find highest common multiples and, highest common factor and lowest common multiples. I do that all the time. So highest common factor and lowest common multiples. But you need to have 2 numbers for that. So this is just a process. Now, because you guys are undoubtedly amazing, we can actually write this in a shorter way using index notation. All right, so index notation would mean that then becomes equal to 2 with a floaty 3 times 3. Now, when we write things like that, we tend to put the times sign in between them. It makes it look a lot simpler because otherwise we'd end up with 2 with a floaty 3 and a 3. And if you've got really bad handwriting, like mine is sometimes, it doesn't necessarily work particularly well. It's horrible, all right? So there we go. So what we've just done there is actually called prime factorisation. I'll do it again, do a different number. All right, so here's a second example. So we'll call this EG2, and let's do 60. All right, so we're going to split that in. We only ever split it into 2. So because 60 is even, we're going to do 2, and I know that becomes 30. There we go. I've got a prime number. I'm going to put that there. Now, again, if you're not sure what a prime number is, 2, 3, 5, 7. Now lots of people go 9, and I go no, it's got a 3 in it. 11, 13, 17, 19. Those are the first few. All right, now generally speaking, we tend to just divide by 2, 3, 5, and 7. All right, those are the ones we tend to find that we use the most. So let me go. 30 is 2, because 30 is even, times 15. All right, we've got, yep, let's split that up, 15. Well, 15 now isn't an even number, it's an odd number. So what does it divide by? 2 doesn't go 3. And notice how I go up in all of those values. So I'm going to do that by 3 and 5. And what we notice there, ladies and gentlemen, is yay, we in fact have our end. We've reached the end. So we now know that 60 can be written as 2 times 2 times 3 times 5. Or if we're going to use index notation, we would do that as 2 squared times 3 times 5. Ka-ching. Thank you very much for that. There is prime factorization. All right, now how do we use this? All right, well, we use this to help us find lowest common multiples and highest common factors. Right, now let's do this sensibly. So let's do an example. And I'm really, really lucky that my examples come from Cambridge, who very kindly allowed me to use their examples. So let's find both the lowest common multiple and the highest common factor of the numbers 105 and 90. All right, so follow the process through. When we do this, the first thing we do is we actually do the prime factorization for both of those numbers. So let me see, that's not going to be an even number, so I'm going to divide that by 3. And you're going to say, how do you know how many 3's go into that? Well, I actually tend to do short division in my head. How do I do that? Well, I go 3's into 10, go 3 times remainder 1, and 3's into 15 go 5 times. So I now know that becomes 35. There is a circle, and let's see whether we can split that up. Well, 3, no, 5. I'm going to do 5 into there. So 5 goes into there, 5, 10, 15, 20, 25, 30, 35, 7 times. Ka-ching, ladies and gentlemen. There is a prime number, there is a prime number. So I now know that 105 can be written as 3 times 5 times 7. I'm now going to do exactly the same thing with the number 90. Let's move it over slightly, so I've got a bit of room. 2's go into there. How many times? 45 times. Put a circle, 45. Now, obviously, in this situation, this tends to work better if you know your times tables. But I'm going to put 5 into there. 5, 10, 15, 20, 25, 30, 35, 40, 45. Notice I'm using my fingers. I am old as the sun, and stupidly did not learn my times tables in the rote learning way. So there we go, 2 times 5 times 3 times 3. So we now know that 90 is 2 times, let's write them actually in order, because we tend to write these in order, 2 times 3 times 3 times 5, or 2 times 3 squared times 5. Now you're going to turn around and say, how on earth does that help me with this lowest common multiple and highest common factor? Well, I'm going to leave just those on. So using this, we can find our highest common factor and our lowest common multiple. Now, obviously, the highest common factor is the biggest number that will divide into both of those numbers, 105 and 90, which is the biggest number that divides into both of those, or the biggest number they share. Anyway, so highest common factor. Now you can say, what on earth does this have to do with the price of fish? What I'm going to do now is I'm going to write down 105, and I'm going to write down 3 times 5 times 7. You're going to say, huh? Now this is a bit of a process. You write down the 90. Now this is where life becomes funky, because what I'm now going to do is I'm going to match each of these with a number in there. So like place value, remember like units, tens and hundreds and thousands and tens of thousands and hundreds of thousands, whatever else. So there is a 2 here. Now there's not a matching 2, so I'm just going to do 2 times there, make its own column. Then I've got 3 squared times by 5. So what I mean by this, and I always draw a line now, is I've lined up the 3's and I've lined up the 5's. Don't worry about the powers for this moment in time. So to find the highest common factor, we look for where there is a number or the same number in each column. All right, so what I'm saying is here, we only see a number 2 in one of the columns, so I'm not going to write that one down. But because I have a 3 and a 5 repeated, I'm going to write 3 times 5, and actually, ladies and gentlemen, there is my highest common factor. The largest number that will go into both 90 and 105 is 15. Now again, this process can't be done without prime decomposition. Now, can we use the same table to find our lowest common multiple, LCM? Now again, this is the first number that multiplies 90 and 105 to give the same thing. So the first where I do my 90 times table, my 105 times table, and one of those numbers will be the same. Everywhere there is a number in a column, you use that number, including the highest floating number. So what I'm now saying is, let's rub out my arrows here. So there's a number 2 in there, I'm going to write 2. There is a 3 in both of these columns, but the highest power is 3 squared. There is a 5, and there is a 7. Now again, this is an algorithm. That means it's something that you just follow and you just do and you make notes on. So let's have a look, see what happens. So that becomes 2 times 3 squared is 9, times 5 times 7. So 2 times 9 is 18. And 18 times 35 is, now again, if you don't know how to multiply things, I always tend to do it this way. I split 18 up into 10 and 8, and 35 up into 30 and 5. I don't like long multiplication, so what I do now is I multiply each of those boxes together. 30 times 10 is 300, 30 times 8 is 240, 5 times 10 is 50, 5 times 8 is 40, and you add those together. So when I add those two together, I get 540, 580, 590, 630. So there we go. So I now know that my lowest common multiple is 630. Now I chose some pretty disgusting numbers there, or Cambridge chose some pretty disgusting numbers there, didn't they? Yes? Why don't we just do another example just to show you? All right, so again, from the Cambridge book. So now it says, let's have the lowest common multiple and highest common factor of the number 63 and 27. Ooh, we can do this. Right, so again, let's do 63 here and draw a dotted line, and I'm going to do 27 here. So numbers that go into this not, so I'm going to try 3, that tends to work, which goes into there 21 times. I know 3 goes into there 7 times. So we now know that 63 is the same as 3 times 7, or we can write that as 3 squared times 7. 27 is 3 times 9. There is a prime number. That's 3 times 3. And so here, that's just written as 3 times 3 times 3, which is 3 with a floaty 3. Right, what do we do now? Well, if we remember rightly, we do our columns where there's the same thing. So we've got 3 squared times 7 for 63. And for 27, we've got, what have we got? We've got just 3 cubed. So then drawing a line, what do we have? So in this situation, what we're now going to do is we notice that they've both got a 3, but we choose the lowest floaty number. So that becomes 3 squared, which is 9. So we now know my highest common factor is equal to 9. And if you remember, when we do the lowest common multiple, we take the highest floaty number and every number in every column. So what I mean by that is, if we look at this, the highest floating number is 3 cubed. If we look at this one here, we've got a 7, so we have to do the times by 7, right? So we know that then 3 cubed is 27. So 27 times 7 gives me 49. 7, 7, 49. 2, 7, 14, 189. Okay? So just remind yourself what that means. The highest common factor is the biggest number that can divide into, and the lowest common multiple is, if I was to write out my 63 times table and my 27 times table, the first number that they would agree, or the first multiple of 63 and 27, where the number would be the same, is 189. Finally, divisibility tests. I love divisibility tests. So basically, these are the type of things you just need to memorize, right? We know, for example, that all even numbers, okay, are divisible by 2. We just know that. They're either odd or they're even. So here, we know that a number is divisible by 2 if it ends in the digit 0, 2, 4, 6, or 8. Paching, that just means it's an even number. All right, so apparently, a number is divisible by 3 if the sum of all the digits is divisible by 3. That's awesome. So, and they give you an example, 162. If we do 1 plus 6 plus 2, it's 9. That's divisible by 3. Ka-ching. 4 is divisible by 4 if the last 2 digits is divisible by 4. That's awesome. All right, 5, if the last digit is 0 or 5, we tend to know that one. All right, most people know that one. 6, if it's divisible by both 2 and by 3. So we'd have to run the rules there to see if it's divisible by 2, which it's an even number. If it's divisible by 3 as well, then it would be divisible by 6. 8, if the number formed from the last 3 digits is divisible by 8. So if the last 3 numbers are divisible by 8, it's divisible by 8. 9, if the sum of all the digits is divisible by 9. This stuff is amazing. 10 is if the last digit is 0 and there is no simple test for divisibility by 7. That stuff is amazing. To me, that's the stuff you should be rote learning. All right, guys, I'm done. Thank you very much for your time. Hopefully you found this lesson enjoyable. All right, hope to see you in another one. Take care, like, subscribe, and let your mates know about mathsguru.com. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.